of x plus 10. Questions so far? Good so far? And then divide by 2. So we do have to divide everything by 2, so I get negative 1 half x plus 5. I'm going to go ahead and graph that line. It has a...
Is it the same thing to do like negative x over 2?
It is. You might have a harder time figuring out what the slope is. Do you know what I mean by that?
Oh, yeah.
And so when you go ask yourself what's the slope, you'll have to go, okay, oh, that's negative 1 half. So it's the same thing. 5 is the y-intercept. Down 1, right 2. Normally I don't plot very many points, but for this particular problem, I'm going to do quite a few. Just to get the accurate line. Okay, and then the second one, we're going to subtract 3x. From both sides. And then divide by -1. So far. So the y-intercept is -2. The slope is 3, so I'm going to go rise 3, run 1. Do those lines intersect? At what point do they intersect at? 2, 4. Good. Would our calculator find that for us? Probably more accurately than I can. Now on this one it worked out perfect where it hit exactly the point so I could find it. But we could type those in y equals and do second trace. You tell me, how would you find that? Try it in your calculator. Go do it real quick. Make sure we don't. So find the intersection of your calculator, make sure we didn't mess up by incorrect graph. Did you get 2, 4 in your calculator? So go to your y equals. equations. You can do it graphically. Done. So you really already knew how to do this. You might not have known it was solving systems of equations, but you kind of already knew how to do it. And then there are two other options, and those are algebraically. There's substitution and elimination. So we're going to learn substitution and elimination today. Now, one thing that people do sometimes at this point is they go, well, I can do it graphically. Why do I need to listen to anything else? The ACT has gotten really good at these types of problems, at making them where your calculator is useless. And I actually have some ACT problems on the slideshow if we get to them today, so you can kind of see how they will split these to make you use elimination or substitution sometimes. So it is a skill you will want to have. So we're going to solve this set of equations 3 ways. We already did it graphically, right? This is the same one as well. So we already did it graphically. We got x equals 2 and y equals 4. So now we're going to do 2 other options, and that's substitution and elimination. How many of you remember doing this in another class? New to most of you. To do substitution, what we're going to do is first get a variable by itself. Which variable looks easiest to get by itself? In either equation, it doesn't matter which one. The x, I heard someone say the x on the bottom equation. I agree. If you had said the y on the top equation, I would have said yes. Either one of those are 2 good choices. Probably the x is a little easier if you hadn't already done the bell ringer. So I'm going to get x by itself. So I know that x equals negative 2y plus 6. So you might want to write in your notes, step 1, get a variable by itself. Any questions so far? Step 2, substitute that variable into the other equation. I'm going to take that variable and I'm going to put it in for x in the other equation. What do I mean the other equation? What is the other equation? The one on the top, the one that I didn't use yet. Okay, make sure you don't use the same equation twice. It won't work out for you. You'll get an incorrect answer. So make sure you use the other equation. So I'm going to take that top equation and I'm going to write 3 times minus y equals 2. Where that x was, I'm going to substitute in negative 2y plus 6. I'm going to solve that equation for the variable that's in it. Could have been x, it could have been y, depends on what you picked in your substitution. So we're going to solve for x or y, whichever one it is. In this case, it's y. So I have negative 6y plus 30 minus y equals 2. Okay, with what I'm doing so far, distributing. Combine like terms. The negative 6 minus the y is negative 7y. Subtract the 30 from both sides. Divide by negative 7. So you get y equals 4. Any questions so far? Sign out. There's one more step. I have x, but what, or I have y, but what do I not have? X. So go back. You can plug it into either equation to find the x. Plug that into either equation to find the other variable. However, we do have an equation with x already by itself, right? That would make your life a little easier choosing that because you want to find x. So I know that x, someone remind me, what was the equation x equals what? Negative 2y plus 10. So I'm going to put that y in for y. Negative 8 plus 10 is 2. So I get x equals 2, y equals 4. Is that the same thing I got graphically? Yes. And so we definitely like graphically. Now don't forget we did have to do some work for that, so we had to get y by itself there too. But this is substitution. Second option is substitution. Any questions? Third option is elimination. To me, I think elimination is ACT's favorite. It seems like they set up their problems to where elimination is the easiest way to do it. So again, don't tune out any of the three options. You need to done all. Just look at it and making you use a combination of the three. So to do elimination, we're going to take these two equations and line them up with the x's and y's stacked underneath each other. So step 1, stack the x's and y's underneath each other. This one was already set up that way, so I didn't actually do anything. But if it were rearranged, you have to line them up with the x's lined up and the y's lined up. Step 2, multiply one of the equations, or both, by a number to get a variable to eliminate. So after you have time to write that down, I'll show you what that means. So I either want the x's to go away when I add, or I want the y's to go away when I add. So I can either multiply the top equation by 2. Why would I pick 2? If I put a 2 here, what would happen to those y's if I add them together? They cancel. Or I can multiply the bottom one by negative 3. Why would that work? Because they cancel. Now don't do both. Pick one or the other. But multiply one of the two equations. Sometimes you have to multiply both if there's nothing alike. But multiply one of the two equations by a number to get one of the variables to eliminate. It doesn't make any difference which one. I'm going to pick the bottom one, but again, whichever one you want to pick works great. So we're going to leave the top equation alone. Let the bottom equation everything on the bottom by -3. Everything on the whole equation. Say that again. I'm multiplying each piece. So every piece by -3. How many of you, now that we start doing this, have seen this before? Even more of you now that you've seen it. We're going to add those two equations together. Step 3. What is 2y times -3? So you have to multiply everything by. So step 3, add the equations together. Add those equations together. And if I do, what happens? So then 3x and a -3x, we set it up this way, but what happens? That cancels and I get 0. -y plus -6y gives me -7y. 2 plus -30 gives me -28. Does this look familiar to you? Yeah, a similar thing happened with substitution, because even though it's a different method, we kind of notice some parallels. Divide by the -7. So step 4 would be solve for y. Solve for x or y. And what do you think step 5 is? Plug it back into one of the other either equations and solve for the other variable. So step 5. Sometimes they will give you two lines that are really the exact same line. You put them in slope-intercept form, you get the exact same line. And they'll ask you, what's the solution to that? Well, where does that line cross? Every point, right? Does everyone agree that every point on that line is a solution? Because every point on it is on the other one also. So the solution, we're going to say there are infinitely many solutions. We're not going to say all real numbers because this is not a solution, correct? It's all the numbers on that line are the solutions. So infinitely many solutions is the way we're going to answer that question.
So if there's only one line, it'll always be that way.
Mm-hmm. Yes, they give you two lines that are the same line. Okay, so we're going to look at a couple more, but now we want to solve it however we want to. So we're going to look at this one that I have here. Someone tell me, what is the easiest way to solve this problem? Elimination. Why? It's already set up for elimination, and it even already cancels. I don't have to multiply by anything. Does everyone see that? ACT does this a lot. So elimination is something you'll want to have in your toolbox. So I just add them up. I get to skip step one, don't I? Really step 1 and 2. It's already done for me. So if I add them up, what do I get? Two x equals negative 6. Does everyone agree? Add the x's. 1x plus 1x is 2x. Negative 6 plus 0. What happens to the y's? They cancel. Negative 2 plus positive 2. So I get x equals negative 3. Am I finished? No. What do I have to do to finish? Find y. Plug that in where? Either one. Pick either equation at the top. Good? Either equation at the top. So I get negative 3 plus 2y equals 0. And now what? Add the 3 over. Divide by 2. So the answer is y equals 3 over 2 and x equals negative 3. So this is what your homework will look more like. One option. Now, I do want to mention, because some of you probably are going, no, graphing would still be easier. What would you have to do in order to graph both of those lines? You'd have to get y by itself twice, right? And neither one of those have to quit, do they? So, would it be just as long using a calculator on this problem? Now, if they give you the problem in y equals format already, what's your best option? Graph it, right? So, just choose the best option for you. The next one, I think you have some options. I still think it's set up pretty well for elimination, but I would rule out substitution if you like substitution. What do y'all want to do? Substitution? Let's do it. Okay, so I'm going to do substitution. If I do substitution, what would I want to do first? Get a variable by itself. Which one looks easier? The x on the bottom, because I can just move the 3y over. So I used the bottom equation. Let yourself know you already used it, because why do I need to let myself know that? I have to put it into the other equation if I'm using substitution. By the way, I'm doing substitution on this one, but if you wanted to do elimination, if you multiply the bottom equation by 2, Does everyone agree that'd be pretty easy? Not too bad. So elimination works great too. Okay, I'm going to put that equation into the top equation. Okay. Okay so far? Good so far? Yes? Yes. Okay. So I get 6y minus 12 minus 6y equals negative 12. What is 6y minus 6y? 0. So I get negative 12 equals negative 12. I didn't mess up. If I were to have done elimination really quick glance up there, if I were to multiply this bottom equation by negative 2, wouldn't I get negative 2x minus 6y equals negative 12? Is that and that the exact same equation? So it's the same line, right? What does that mean if you have the same line? Infinitely many solutions. Now, let's talk about the negative 12 equals negative 12. When does negative 12 equal negative 12? Always, right? At every x and y, negative 12 equals negative 12, right? So this makes sense for the infinitely many solution answer. If you ever end up with 6 equals 12, that does not make sense, does it? That would be a no solution answer. So if you end up with one that doesn't make sense, it's a no solution. If you end up with a number equals a number, it's infinitely many. Does that make sense? Okay, let's try this one. Since I used substitution on the last one, I'm going to use elimination on this one. It doesn't really matter. Change it up. What? So say we want to multiply the bottom equation. You really can do either one. What would you multiply the bottom equation to actually make this eliminate? Negative 2. Why negative 2? Everyone agree that'll make that 2 cancel the m? So I have 2m minus n equals 10. That was the top equation. My bottom equation now becomes negative 2m plus 4n equals 8. Stall there for a minute, make sure that's making sense. Okay, bring that air down. The hot heat. Just teeny tiny. Okay, any questions so far? Negative 2. Does that make sense? Now, if it doesn't do this easily, pick another method, right? You don't have to use elimination. But this one's pretty easy. I just multiply the bottom equation by negative 2. Add down, what happens to the 2n minus 2n? Cancel, so I get 0. Negative n plus 4. 10 plus 8. And so n is 6. And then how would you find m? Plug it into either of the top 2 equations. I'm going to use the bottom one, but it makes no difference. Where that n was, I'm going to put 6. 2 times 6 is 12. So m is 8, n is 6. You should always get an m and an n or an x and a y for your solution unless the answer is total solution or all whole numbers. Okay, I have some ACT problems, but before I write this down, I think I'll have time to do something. certain shape it would otherwise, I think you can tell. Okay. You don't have to write this down, but you might, print it off later or something. This is often how system equations go with me. Very often how the ACT puts system equations problems on the ACT. This one's a pretty hard one. It's number 41 on the ACT, so it's a later problem. It's up one. It says the equations below are linear, where A, B, and C are integers. Which of the following describes a set of lines? Two parallel lines, two intersecting lines, or a single line? Well, we know that if we get 0 over 0, or 0 equals 0, or something like that, then they're the same line. If we get a number equals a different number, they're parallel lines. And if we actually get an answer, they're intersecting, right? They can set this up very well for elimination, because the B's already cancel if you add down. So you get 2AY equals 2C. Could you get Y by itself? So this is two intersecting lines. I can find an answer. Now, if this had been a negative AY, like that, then I would get 0 equals 2C. That would be two parallel lines. If this were also a negative C, then I would get 0 equals 0, and I would have the same line. So that's how they can rearrange this question. But this one was an interesting one. I'm definitely set up for elimination. Any questions for that? Okay, this is a little bit easier one, but it's actually number 49. Alright, it's a little easier. You could do any option on this one, substitution elimination. For what value of A would the following system have an infinite number of